Assalamualaikum and good evening to Dr. Ehsan and my fellow classmates. So today, me and Khalif would like to present our summarization regarding open hole wireline logging operation that we have studied for the past few weeks. So in this presentation, we will cover three parts of our content. The first part of our content is regarding introduction, which we will discuss regarding open hole wireline logging objective and tools. And we will move on to the next part, which is the open hole logging tools details and descriptions. And lastly, we will end this presentation with data log analysis that we have been interpreted. Moving on onto the first part of our presentation, which is introduction of open hole wireline logging. Here we will discuss the objective and some background information regarding the operation logging. So, open hole wireline logging. There are three main objectives of open hole wire logging. The first is to find reservoir rock quality, hydrocarbons, and source rocks in exploration wells. The second objective is to support volumetric estimates and geological modeling during field appraisal and development. The last and the main objective for open hole wireline logging is to provide a means of monitoring the distribution of remaining hydrocarbon during the production lifetime. Usually, open hole wireline logging is done on two types of well. The first type is exploration and appraisal wells, and the second type is development wells. Open hole wireline logging is very costly. It takes up about 5 to 15% of total well cost, so we need to carefully manage before start our wireline logging operation. Open hole wireline logging also contains many logging tools such as induction devices, micro resistivity, litho density and neutron porosity, and acoustic tools. The labeling of each tool is difference between each company. For Schlumberger, induction devices are labeled as DIL or DLL, while Atlas is labeled as DIFL or DLL. Same goes to all other type of logging tools. Alright, that's all about the introduction of open hole wireline logging. So now we will move on to the next section, which is the open hole logging tools details. In here, we will discuss the logging tool functions and how to read the measurement from the data that we have captured from these tools. In this presentation, we will discuss about a total of 8 open hole wireline logging tools. The first one will be gamma ray log. As you can see on the left side of these slides, we can see how gamma ray tool looks like in our borehole. Typical of application of gamma ray log usually used to determine the reservoir thickness, to indicate the lithology, to correlate between the wells, and to estimate the shale volume. The principal measurement of gamma ray log is to record the current rate of gamma emission from the formation, from the decay of radioactive isotopes such as potassium, uranium, and thorium. Here we can see the gamma ray reading of common rock that we can find. For example, sandstone and dolomite have gamma ray reading ranging from 10 to 20. Halite and coal is 0 gamma ray reading, and same goes to other type of rock that we can see in the table inside here. Moving on to the second type of wireline logging tools, which is spontaneous potential log or SP log. On the left side of the slides, we can see how SP log look like in our borehole, usually used to determine the reservoir thickness, to indicate permeability, and to estimate the formation of water resistivity. The principle of measurement of SP log is to record the difference between the electrical potential of a movable electrode. Variation in the borehole potential will result from electric currents flowing in the muds. So the interpretation of SP log is the SP log deflection will only occur opposite the permeable zones. If the formation water salinity is higher than the salinity of mud filtrate, the reading will be negative. If the formation of water salinity is less than the salinity of mud filtrate, the reading will be positive. Moving on to the third open hole wireline logging tools, which is the formation density log. As you can see on the left side of the slide, here is how formation density tools looks like in our borehole, usually used to determine the porosity and to indicate the lithology in our formations. The principle of measurement for formation density log, it records the gamma ray count that have been scattered in the formation, and the gamma ray count is inversely proportional to the electron formation density tools, which means the higher the number of gamma ray counts, the lower the number of electron in our formation density tool. Here are the examples of the reading of density in our formation. For example, quartz is 2.65, calcite and 2.71, and same goes to the density of pore fluid. Moving on onto the fourth open hole wireline logging tool, which is neutron logging. As you can see on the left side of the slide is how our neutron porosity tools look like in our borehole. It used to determine the porosity and also to indicate the lithology and gas in our formation. The principle of measurement of neutron logging is the neutron logging tools will record the captured neutron in the formation, and the neutron population also indicate the hydrogen amount in the formation, which is water, and the water will also indicate the formation porosity. Here we can say that the number of neutron population also indicates the number of the porosity. The interpretation of neutron logging is, for gas field formation, the reading will have a low hydrogen population, which also indicate low porosity. And for shell formation, neutron logging tools has high hydrogen reading, high hydrogen population, which indicate high porosity. Now I will pass the presentation to Mr. Khalif to continue on other four types of open hole wireline logging tools.
Yeah, thank you, Mr. Farid. And moving on to the fifth wireline logging tools, which is the sonic log. As you can see on the diagram on the left, which is demonstrated on how the log will be used in the formation. As the label for the T is the transmitter, and both R's are the receiver. And the typical uses for this log includes the calibration of seismic velocity and also as an indicator of the lithology formation. And the basic principle of measurement, it is used by recording against the depth of time travel of acoustic pulse to the borehole formation. So in a way, it is a it is a bit similar on how seismic reflection was applied. And it records by measuring the pulse arrival time at two receiver, which mean the different lithology will have the different pulse time arrival. And and here the example of interpretation is the sensor matrix with a travel time of 51 to 55.5 microsecond per feet. And the second example is the limestone matrix, which is different from the sandstone, which is for 43.5 to 48. As I said before, different lithology leads to different time travel. On the six wireline logging tools are the lateral logs and the spherically focused logs. As you can see on the left window, there are two diagrams, which are the lateral log tools and the spherically focused tool. Both both of the diagram demonstrate how the focus current are coming from and which part is the measuring current that will be used into obtaining the final result. And the typical application for both of these for both of these logs are determining the hydrocarbon saturation and while also serve as an indicator for permeability. The principle of measurement is that these logs operates by focusing currents to force a measuring current into a planar disc shapes and monitor the potential drop between electrodes on the tool and the distant electrode. The first part is the lateral logs, and and for the second part is the spherically focused logs operates by focusing and measuring currents to establish spherical equipotential shells in the formation around the tools. Equipotential in theory means in space or region where all the points have the same potential. And for the interpretation window, both the shallow invasion and deep invasion show have a high resistivity value as represented by the arrow on the right. For the shallow invasion, both lateral log both lateral logs and spherically focused logs have a higher resistive value which can result in the lithology formation as sand or sandstone. The difference between the shallow invasion and deep invasion is that the LLS or lateral log shallow have a slight lower value compared to the LLD or the lateral log value. Moving on to the seven wireline logging tools is the induction log. And on the left image is demonstrate how the induction tool will be used in the formation as the transmitter is on the bottom and the receiver is on the top. The transmitter emits an induced current which then received by the receiver. Typical application for the log includes includes the determination of hydrocarbon saturation and also as an indicator for permeability. The principle of measurement of these logs is by using alternating magnetic field to to the use of high frequency alternating current, which induce which then induce current flow proportional to the formation conductivity and creates a magnetic field, and which then sets up a voltage in a receiver coil. The interpretation part, the induction deep and the induction medium logs can be used to establish resistivity results, and the determination of resistivity from induction logs as a parameter in the hydrocarbon saturation calculation is almost identical to lateral logs, which mean both lateral log and the induction logs use resistivity to obtain the final results in determining the hydrocarbon saturation and also indicating the permeability of the formation. And for the final or the eighth wireline logging tools is the formation pressure tester. On the left window, you can see how the large tool is connected to the formation and gives you a basic way of how the tool is used within the formation. And the typical use for this tool is that it can apply as a measurement of formation pressure, depletion profiling, and also for formation fluid sampling. The principle of measurement for this tester is first the tool the tool which is an accurate pressure gauge is attached to a probe which then extended down into the borehole connecting both the formation and the tool. This way, permeability can be estimated by drawing down at a fixed rate a small piston connected to the flow line, and the resulting pressure drop magnitudes gives an indication of the formation deliverability. So how do we interpret this? by constructing a pressure versus two vertical depth plot to establish pressure distribution and fluid gradient. And the oil and water gradient and from the graph or the plot, the oil and water gradients intersection will identify zones of good permeability. Moving on to the last part of our presentation, which is the well log data analysis, where we will be interpreting an example of a well log data. Here is our set well log data and our interpretation. And firstly, we can see the caliper log has a smooth straight line reading, which indicates that there is no formation collapse throughout the borehole. And for the first part, because of the high gamma ray value, we conclude that it is a shale lithology and also a high porosity region as indicated by the high neutron value. And after that, it is the sandstone lithology as represented by the low gamma ray value and also quartz matrix. The low neutron value indicates that it is a low porosity, and the low sonic value indicates that the possibility of gas presence. And after that, from the gamma ray reading, we can conclude that after the sandstone is it is the shale lithology and sandstone lithology. And after the sandstone lithology, we we conclude that the region is sandstone and or limestone as indicated by the low gamma ray value. And after sandstone and limestone, it, we we come we come to conclude that it is a sandstone region as indicated by the low gamma ray value, sandstone and quartz matrix, and the low neutron value indicates that it is a low porosity region, and the low sonic value also indicates that there is a possibility of gas presence in the formation. And lastly, the high gamma ray value indicates that it is a shale lithology, with the high neutron value indicates that it is a high porosity region, and the quite high sonic value indicates that there is a presence of water in the shale formation. We have come to the end of our presentation. Throughout our video presentation, we have covered the 8 types of wildland logging tools, explained their brief description, and also how they were used in the formation. And we have also interpret a well log data th- based on an example that was given to us. So that is all for me and Mr. Farid. Thank thank you. Thank you for your time, and thank you for listening to our video presentation.